In this lesson, we're going to be going over UNIX tools. One of the advantages of using a Unix-like operating system for doing computer forensics work is that there are a number of tools that are just built into the operating system that make doing that work at least a little bit easier, if not considerably easier. The other advantage is that the tools are just built in. You don't have to go download anything in order to get the tools working and have the tools that you need to do the job. So we're going to go over some of those tools that are built into Unix-like operating systems, and that would include Linux, which is what I am working on right now. So let's start with the tool DD. Now, the tool DD is used for getting images of disks. DD is really sort of short for disk dump, and the idea behind DD was that you could do an entire dump of a disk to another disk in order to create a bit-for-bit copy. So there's a lot of uses for DD, and particularly for forensics work, what we use it for is to get a clean bit-for-bit copy of a hard drive or a partition or some other sort of digital media so that we can do work on the copy and leave the original as is. And the reason that we would use a tool like DD is because we get an image that is reflective of what is actually on the source media. There's no alterations, nothing gets hidden. Everything that's there, including slack space, including recycle bins, including the partition table, everything that we could need on that hard drive for doing our work will actually be copied over using DD. Another use of DD is if you just want to get the master boot record of a particular image, you could do something like this, where you specify the input file as the hard drive for the disk that you are looking for the master boot record for, and then you can say output file is boot.img, for example. We only want 512 bytes because that's the size of a sector on a hard drive, and the boot record is only 512 bytes. So we say block size is 512 bytes, and I only want one of them. So here's the output. I've got 512 bytes of the primary hard drive on this particular system, and I used sudo because I can't access the hard drive without administrative privileges. So that's DD. Now, what I can also use is a utility called MD5sum, and that typically comes with Unix-like operating systems, particularly Linux. Linux would come with MD5sum standard, or at least give you the ability to easily get access to it. The same with SHA-1 hashing utilities. We can get access easily to those SHA-1 utilities if, in fact, they aren't standard on the particular Linux distribution that you're using. So in order to get an MD5sum, I'm going to work with the boot.img file that we just created, and I'm going to get an MD5sum of it. So what MD5sum did was looked at the file that's 512 bytes and created a cryptographic hash of that file using the MD5 algorithm, and you can see the output here from using MD5sum. Now, if I wanted to transmit this particular file to somebody, I could send them the MD5sum or somehow communicate the MD5sum or checksum to them, so when they received the boot image file, they could also do an MD5sum and then compare the hashes. And if the hashes are the same, then the file got there intact. If they're different, then the file has been altered somehow, or it's been corrupted, and it's not the same as the original. So MD5sum is another utility that would come with many, if not most, Linux distributions or other Unix-like distributions or operating systems. Another tool that comes with Unix-like operating systems is something called strings. Now, what strings does is it looks through binary files and looks for printable characters or strings from that file. So what I want to do is find an executable and I want to run strings against it. So I could do something like this. I could run strings against the bash utility, which comes as the standard shell for most Linux distributions. And you can see here what I get from that is right here at the bottom, I'm getting a lot of error messages that would get printed when the shell ran into error conditions. And there are a number of other strings that come as part of that utility, and you can see all of them here. One thing you can look for as part of this is different libraries that may be included, or help messages, or other parts of the program that may provide useful information as to what the program is doing or how it behaves. And this is helpful in the case of malware or other types of attack software. When you're doing a static analysis on that, you probably want to run strings against it so that you can see what's actually in there and maybe get some basic idea as to how the program operates based on error messages or libraries that it connects to or other types of strings that are in the file. Now, if you've got a file that you need to go looking for information in, you probably want the utility grep. And grep stands for Global Replace. It's really the same thing as you would get in a program like Microsoft Word. If you needed to go looking for particular words or phrases in your Word document, or you wanted to be able to find those words or phrases and replace them with something else, grep does the same thing in a command line way in Unix-like operating systems. So if I wanted to look for the term error in the file bin/bash, then I could do grep error/bin/bash. It says binary file bin bash matches, so it was able to find that. Now I could also do something like this and grep for error. So I'm piping the output of the strings file to grep so that I could actually see what messages in bin/bash or what strings in bin bash are there with the error word in it. So I can see all of these messages that were in /bin/bash and include the word error. If I wanted to search an entire directory for something, I could do, say I want to look for read, the word read in all of the files in my home directory. And you can see here's the output of everything that's here. It shows me a lot of log files and a bunch of other things, but they all have the word read in common, and grep is able to look through a number of files. And you can also do recursive grep, where I could do the same thing, and that would look through all of the directories inside the directory that I'm in. So it looks in the top level directory where you are and then looks through all of the subdirectories as well. And that's called a recursive grep because it goes recursively through all of the subdirectories in the particular directory or folder where you are. So grep is a really handy tool to have in order to quickly and easily search for data that you may need to find. Another tool that is helpful is the tool fdisk. And I'm using this against the drive that's the primary hard drive in this particular system, but I could use it on any drive and I would be able to look at the partition table. So I can print the partition table here and we can see that there is a Linux partition and a swap partition. There's also a GUID partition table, which also has a partition entry as well. So fdisk tells you what partitions may be available on a particular hard drive. In the case where maybe an operating system is hiding a partition, you can actually use a tool like fdisk to look at the partition table or have fdisk read the partition table for you and print out what's in that partition table in a human readable fashion. Now, the other thing that fdisk is good for is it shows you all of the disk geometry. So it tells me that this particular disk has 255 heads and 63 sectors per track. You get to see how big the hard drive is, as well as the physical layout in terms of the number of platters and heads there are available in a particular hard drive. I can also see the sector size and the I/O size. So fdisk has a lot of useful information that it can present to you. Now, fdisk isn't the only utility that you can use to get this particular information, but it's a good one to get partition information as well as information about the drive. So as I said, Unix-like operating systems like Linux come with a lot of really useful built-in tools and utilities, which you may find really useful as a forensic examiner, and it may be helpful to get some familiarity with Linux, particularly at the command line level, because command line is really kind of the least common denominator, and no matter what graphical interface you may be running, whether it's GNOME or KDE or Cinnamon or XFCE, no matter what graphical interface you're using, the command line tools are always going to be there. You may not always have the graphical tools, but the command line tools will always be there no matter what particular Linux distribution that you're using.